Welcome back, guys. I hope all of you will be fine. So this was question 3.11 which we have done previously, and here we have seen that what did we find out. This was the statement, and on the basis of this statement we have found out the probability density function for different values which are plotted here. So these are the values and their plots are given here. Okay, so on the basis of it we are asked to find the construct a graph of the cumulative distribution function of exercise problem 3.15 or 3.11. That is basically the PDF which we wanted to find out the cumulative graph of which. Okay, so this is what this is question 3.16, and let me proceed to the question 3.16 here as well, and I'm going to use the same page here. Okay, so let me have it here, and here I am going to draw the CDF of it. Okay, this is PDF. The first one is basically the PDF, and now I am going to plot the CDF for it. Okay, so let me do it again. This is the PDF. Okay, and now I want to find the CDF or plot it. Okay, in order to find the CDF, what do I have to do? Let me have it here, and let me draw it here as well. I'm sorry for my drawing. Okay, and if the PDF represented by small f of x, CDF is represented by capital F of x. Okay, but the domain of it will remain the same. This is x, and all small x are the members of this capital X, which is the random variable. Okay, so here I have different values which are 0, 1 and 2. Okay, so let me draw them here. In order to draw it, let me use the color which is blue here, and in order to do so, let me first draw it for 0, and for 0 it is 2 by 7. Okay, let me have it here, and this is here, this is 2 by 7, and it will proceed unless and until I will get here to this 1. Okay, when I will get to this one, what will happen? This 2 by 7 will be added with the value which is at 1, and this is 4 by 7, so it will be 4 by 7 here, and it will be added at this instant which is 1. At 1 it will become 6 by 7. Okay, so this is 4 by 2 by 7, so now it will become, let me have here this 6 by 7. Okay, so it will jump here, and it will move unless and until I will get here 2. Okay, when it will reach 2, what will happen here? The value of the PDF at 2 is 1 by 7, so this will be added. This 6 by 7 will be added with 1 by 7 at what? This was at this point, and now we are at 2, so at 2 we have this 6 by 7 plus 1 by 7, so it will be equal to 1. Okay, so it is now 1, and it we will move here, and here it will remain 1 forever. Okay, so this is what, this is the CDF plot of our question. Okay, now in order to write it mathematically, let me write it mathematically, and here in order to write it, let me move down somehow more. Okay, so here this would be f of x. Okay, and this f of x would be what? 0 for all the values of x which are less than 0. Okay, it will be 0. Similarly, at 0, at the instant when it is 0, and in between 0 and 1, it will be 2 by 7. Okay, so let me write it 2 by 7, and here it will be the value of x would be greater or equal to 0 and less than 1. Okay, at instant 1 it will jump, and it will become 6 by 7, so here it will remain 2 by 7. Okay, so when it will be 2 by 7, here it will jump to the 6 by 7 here. Okay, and here at 6 by 7 it will be at x is greater or equal to 1, but less than, sorry, but less than 2. Okay, here it will be 6 by 7, and the last instant is here when it will be 1, and it will remain 1 for all the values which are x is greater or equal to 2. Okay, so these are all the values which will remain here, and these are the values of what? These are the values of f of x which we have here. Okay, these are the values of the CDF, and we have written it in the form of this graph and this graph as well. Okay, so if you have any question, you can ask me in the comment box. This is the mathematical equation for it. If you have any ambiguity regarding the equations or the graphical illustration, you can ask me in the comment box. So see you soon. Hello guys, welcome to my YouTube channel. So this is question 3.17 of chapter 3, and the statement of it is a continuous random variable x that can assume values between x equal to 1 and x equal to 3 has a density function given by f of x equal to 1 by 2. Okay, so before going into the detailed discussion of this question, let us first see that what is this and what are these values. So in between 1 and 3 this function lies, which is 1 by 2, and it remains constant in between all these values. Okay, so let us first write the given data. So in given data we have word, let us draw it, and in drawing it you will very clearly see that this is word, this is the PDF plot, this is x, this is f of x. Okay, and it has values from 0, 1, 2 and 3. Okay, so it has some values. Now in order to draw it, we have here this value 1 by 2. Okay, and here according to the statement given here, the values lie between 1 up to 3. Okay, and as all these values are continuous, because the random variable here we have is a continuous random variable, so therefore it will be the constant value, or we can see here that it will be like this one. Okay, so this is what, this is the statement of our question. Now in order to solve it, what we have to do, let us see the solution, and in order to solve it I have chosen this place. Okay, and here I have to find the solution of part A, in which I have to show that the area under the curve is equal to 1. I have to find out the area which is given, and this is here in this range. Now in order to find it out, I know that in a continuous random variable, area is equal to the lower range, which is here the 1, up to the higher range, which is 3. Okay, and taking the integral of it, and then writing the value of f of x. Okay, which is what, let me write here the f of x. Okay, d of x. Now here the value of f of x remains constant in between these values. So therefore let me write in, and it will become 1 up to 3, and the value of it is 1 by 2 d of x. Okay, or it will also be like uh, 1, 3, as this is a constant, it will come out of this and it will become d of x. Okay, or ultimately it will give what, it will give, this will be 1 by 2 multiplied by this x. Okay, this x, let me write it here as well, and the ranges which are from 1 to 3. Okay, so now let me solve it, and solving it, what I will get, this is 1 by 2 multiplied by the value of x, higher value which is 3 minus the lower value, and 1 by 2 multiplied by 2, which is basically equal to 1, and that is what, that is the solution of part A, which basically says that the area under this graph or this curve is basically 1. Okay, which is proved here. Okay. So now going towards part B of our question. So this is part B, and here we have to find the probability in which x is greater than 2 and less than 2.5. Okay, I have to find out the probability that x is greater than 2 and less than 2.5. Okay, here I have to do what, again taking the integral, because this is now a continuous random variable, writing the lower limit here, the higher one here. Okay, and the f of x, which is again 1 by 2 d of x. Okay, so again integrating it just like this one, what will we get, we will get the same value which is written here. Okay, so now only the values of the ranges will be different, which are here and here. So now writing them out here, what I will get here, I will get 1 by 2 x, and the values of x are 2, 2.5. Okay, so it will be 2, writing the higher range 2.5 minus 2, okay. So it will be 1 by 2 multiplied by 0.5, okay. So which is ultimately 1 by 4, the solution of what? The solution of part B. Okay. So now this is the solution of part B. Now going towards the solution of part C, in which I have to find out the value in which x is less than or equal to 1.6. Okay. So here I have to find out the probability that this x is less than or equal to, sorry, let me remove it, this one as well. So x is less than or equal to 1.6. Okay. As we can see that this basically lies from 1 to 3. So therefore the x less than 1.6 basically corresponds with the values which are in between 1 and 1.6. So therefore I have to take the integral in between 1 and 1.6, okay, and writing the values here. Again the function here is a constant, so therefore this will be dx, okay. Again the same function, because the f of x is not changing, so therefore it will be 1 by 2 x, and here it will be 1 into 1.6, okay. So now let me solve it here. So it will become 1 and lower value minus higher value minus lower value. So here 1 by 2 multiplied by 1.6, and this is 0.6, okay. So it will become how much? It will become 0.3, okay. So that is what, that is the solution of part C. Okay. So in today's video, we have seen the solution of question 3.17, which had basically part A, B and C, and we have solved them, which is related to the continuous random variable given here. If you have any question, you can ask me in the comment box. See you soon.
Welcome back, guys. I hope all of you will be fine. So this is question 3.18, and the statement of it is a continuous random variable x that can assume values between x equal to 2 and x equal to 5 has a density function given by f of x, which is 2 1 plus x divided by 27. Okay. So first of all, let me write the given data. Okay, and in writing the given data, what I have to do, let me plot it here. So visualizing it will give you the conceptual overview of this question. Okay, so the values here on the x-axis basically starts from 2. Okay, this is 3, this is 4, and this is 5, and all of these values has a value which is f of x equal to 2 1 plus x divided by 27, and as the value of x is available here, we can see that this is a linear function. So most probably it will be like, you can see that it will be like this one. Okay, it will be a linear function. So I have to find it out, and here we have this f of x, okay, and on the x-axis we have this random variable x. Okay, so now here, in order to find different values which are here, let me solve it, and solving it I have to do what? Here we have to find in part A the probability that x is less than 4. Okay, so this x less than 4 basically lies in the range which is basically this one. Sorry. Okay, so this is basically this one. I'm not going beyond this one because now the function is already 0, so I'm not going to describe this one as well. So therefore, now writing this one probability, I have to integrate all these values from 2 up to 4. Okay, in continuous random variable, less than 4 is around in decimal points. So therefore, I'm not discussing it, or I'm not considering it. Therefore, because 3.999 something is less than 4, which is almost equal to 4. So I am also considering the value here as well. So now here we will have f of x, d of x. Okay, now putting their values, what I will get here, this will be 2, 4, the value of f of x is 2, 1 plus x divided by 27. Okay, and here we will have this d of x. Now taking this 2 by 27 out of it, okay, and we will have here 2, 4, 1 plus x dx. Okay, and also 2 by 27, and the values here would be applying the linear property here. What we will have here 2, 4, 1 dx plus 2, 4 this x and dx here as well. Okay, now simplifying it, solving it, what we will get here, I will get 2 by 27, and the values here we will have x, and here 2, 4, and here I will have x square divided by 2, and the values are here again 2 and 4. Okay, also this 2 by 27, and here we will have 4 minus 2 plus this is the higher range in this x, while this is the value lower range value. Similarly here we will have 1 by 2, and now x square higher minus x square lower value. Okay,
Now finding it out, what I will get 2 by 27, and here we will have 4 minus 2, which is 2. Okay, here this is 4, 4, 16, 16 minus 4 is 12, 12 divided by 2 is, that is 6. Okay, so ultimately what we will get, this is 6 plus 2 is 8, 8 multiplied by 2 is 16, so 16 divided by 27, and that is what, that is the solution of part A. Okay, so that is what, that is the solution of part A. Similarly, you can also solve part B just like this one, and what to do in it, we can see that the ranges are given here which are from 3 to 4. So let me solve it here as well. So let me move down somehow. Okay, so now this is part B of my question, and here I have to find the probability that x is greater or equal to 3 and less than 4. Okay, now in order to do so, I have to write these limits. So these will start from 3 to 4, because I have told you that I cannot discriminate between the nearest values in continuous random variable. Writing the same values here, what I will get here, it will be 2, 1 plus x divided by 27 dx. Okay, so again using the same function which we had done previously, the answer or the solution of it will be like this one, while the limits will change, and by solving it like this one, what will you get, you will get the answer of it, which is 1 by 3. Okay, so the answer of it, by solving it and putting all these value, you will get 1 by 3. Okay, so that is what, that is the solution of the question 3.18. If you have any question, you can ask me in the comment box. See you soon.
hello guys, I hope all of you will be fine. So this is question 3.19 of chapter 3, and here we have to go through exercise problem 3.17 and find the f of x, which is what, which is the CDF. Okay, so previously we have seen that in that question we have a uniform PDF which starts from 1 and ends at 3. Okay, and within this range it has a constant value, okay, which is 1 by 2. Okay, so this is for f of x and this is x. Okay, so it has a constant value which is written here. According to this, we have to find what, we have to find the capital F of x. Okay, so now in order to solve it, let me solve it here. So the solution of it is, okay, in order to find it out, what do we have to do? We have to add all these instances here, and as it is basically the continuous random variable, therefore it will start from 1 and will end at infinity, and therefore what we can do here is that we can write this capital F of x. This capital F of x will start from 1 and will move up till this x which is at infinity. So we can find out these values at an instant, and therefore I have to add them. So therefore in order to add them in continuous variables or in continuous form, what do? We use the integration. Okay, so therefore in order to do so, here I have to start this integration from 1. Okay, I have to integrate it from 1 up to what? Up to the value which is at infinity, and let me take it at x and or any value. Okay, this x can be of any value. It can either be from 1.2, 1.3 up till and until any other value. Okay, so this is that x, and here I have to use this f of x, okay, and integrate it with respect to this d of t. Okay, so now let me use these values, and writing these values here, what I will get here, I will get as the value of it is 1 by 2. So this 1 by 2 will be here, and I will take this 1 x and d of t. Okay, now integrating it, and what I will get, it will be 1 by 2, and here I will get what? This will be t, and the values of it are from 1 to x. Okay, now putting these values, what I will get, this will be 1 by 2, and the values of t will be x minus 1. Okay, so what is this? This is the solution of the part A, in which I have found out the CDF of the function which is given here in this form. Okay, so now here by putting any value here, I can find out the CDF of that value. Now by using the same formula, I have to find out the value of the probability in which x is greater than 2 and less than 2.5. Okay, so I have to find out the probability that x is greater than 2 and less than 2.5. Okay, so as I have the value here, so let me have this value here, and here in order to find it out, I have to write here the value at 2.5 minus the value at 2. Okay, now let me put these values, and here I will get 1 by 2, and x minus 1 is 2.5 minus 1, so it will be 1.5. Okay, and minus 1 by 2, and here it will be 2 minus 1 is 1. Okay, so now taking it out, and now 1.5 minus 1. Okay, so ultimately what it will give me, this is 1.5 minus 1, this will be 0.5. So ultimately I will get here 1 by 4, which is the solution of this part. Okay, so now we have found out the probability of different items which lies in different ranges by using the CDF which we have found here. Okay, so that is what we have to identify and solve in question 3.19. If you have any question, you can ask me in the comment box. See you soon.
Welcome back, guys. I hope all of you will be fine. So this is question 3.20 of chapter 3, and the statement of it is for the density function of exercise 3.18. Okay, find f of x, which is basically the CDF, and use it to evaluate p x is greater or equal to 3 and less than 4. Okay, so in exercise 3.18 we had f of x which was equal to the 2 divided by 27 multiplied by 1 plus x. Okay, from x equal to 2 to x equal to 5. Okay, so this was what the probability function was. So now what I have to do now, I have to find the capital F of x, which is the CDF, and in order to do so, what I will do, I will start integrating it starting from 2 up to any value x that would be here. Okay, so let me write here the value of 2 up to any value x, because it is starting from 2 and ending at any value x. So therefore I have to write that value here as well, and also I have to change the domain of it, and as I have been writing here the x, which is basically in accordance with the domain of the CDF. So therefore now I have to change it to the value which is basically t. Okay, so here I have to write 2 by 27, and here let me write here t. Okay, and I have to integrate it up with respect to t. Okay,
So let me write it here, and it will become 2 by 27, and here again integrating from 2x 1 plus t dt. Okay, so now integrating it, what I will get here, I will get 2 by 27. Okay, and also inside of it I will get t plus t square by 2. Okay, and these values which are here, these will be here. Let me write them here from 2 to x. Okay, now after putting these values, what I will get, you can simplify it, and at the end what you will get, here x minus 2 multiplied by x plus 4 whole divided by 27. Okay, this is what, this is basically the capital F of x which I wanted to find out, and this is basically the CDF which we have. Okay, so now in order to find the second part of it, which is finding the probability, and here in order to find the probability that x is greater or equal to 3 and less than 4, what I have to do, I have to include these two ranges in such a way that I have to subtract the lower range CDF from the higher range. Okay, so I have to write here F, capital F of 4, and from it I have to subtract capital F of 3. Okay, so now putting their values and also writing all these values in these equations, because I know the equation for it. So it will become, let me take this 1 by 27 out of both of them because it will be included in both of them. So now for 4, what I will get, x minus 4. So here I will get 4 minus 2, and also here x plus 4, this is 4 plus 4. Okay, similarly subtracting it from the lower limit, which would become here 3 minus 2. Okay, and also x plus 4, that is 3 plus 4. Okay, so now let me simplify it, and here I will get 4 minus 2 is 2, 2 plus 8 is 16, 2 multiplied by 8 is 16. Okay, here I will get 16, and here I will have 3 minus 2 is 1, so 7 multiplied by 1 is 7. Okay, or 1 by 27, and here 16 minus 7 is how much, that is multiplied by 9. Okay, and ultimately I will get here 1 by 3, which is basically the solution of it. Okay, so that's it for today, in which we have found out the CDF for the exercise problem 3.18, and at the end we have also found out the probability between two ranges from the formula we have derived. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 3.21 of chapter 3, and the statement of it is, consider the density function which is f of x k square root of x, and that is in the range of 0 to 1, and it is 0 elsewhere. Okay, so what do we have to do? There is part A and part B. In part A we have to evaluate k, okay, or find the value of k, and in part B find fx and use it to evaluate this value. Okay, so now let me start it from part A, and let me solve it here. This is the solution. Okay, let me solve it here, and in solving it we have this function in the range of this value, and we can very clearly see that in this range the cumulative function or the cumulative value of this function would be what, that would be 1, that would be 1 in between these ranges. Okay, so what do we have to do here? This is basically capital F of x, and that is the cumulation from 0 to 1, and I have to write the value of f of x, where k x, and I have to integrate it in this way. Okay, I can very clearly see that the value of 8 in this range, the value of 8 in this range would be how much? This would be 1. Okay, so let me write this value here. and this would be 1, and here this k is constant. Let me keep it outside, and here integrating it from 0 to 1. Okay, this is what, and here this square root of x is basically x to the power 1 by 2 d of x. Okay, now calculating it, what I will get here, it will be 1 is equal to what, integrating it would be 1 plus 1 by 2 divided by 1 plus 1 by 2. So it would be x 3 by 2 divided by 3 by 2. Okay, and here I also have this k because here I have k. Okay, so now let me use it. Okay, and here keep multiplying both sides by this 3 by 2, what I will get, I will get here 3 by 2 is equal to the k x 3 by 2. Okay, and here as these were the ranges in which I have to integrate, so therefore here I also had 0 1, which will also be here 0 and 1. Okay, now putting these values here for x, what I will get here, I will get 3 by 2 is equal to k, and here this would be 1 3 by 2 minus 0 3 by 2. Okay, and ultimately the value of k will be what, the value of k will be 3 by 2. Okay, so that is what, that is the solution of part A of our question, okay, in which we have found out the value which is 3 by 2. Now proceeding towards the part B of our question, the part B of our question is we have to find f of x. In order to find the f of x, what do I have to do? Now I know the value of k, which is already known. So what do I have to do? I have to integrate my function from the starting point up to any point. Let me take it x, as we have done previously. So this x is any point in between 0 and 1. If I will take the value of x and put it in this function, which I will find now, I will get the CDF of that function. Okay, this f of x, capital F of x, is basically the CDF. Now I have to write the value of k, and after it let me represent this x, which is in the actual equation, with another variable, and let me take as t. Okay, so let me take it t, and this would be t square root, and integrate it with respect to t as well. Okay, so now integrating it and then finding the values, because now the value of k is already known, and that is 3 by 2. So taking this 3 by 2 out of this, and here we will have 0 to x, and this would be t 1 by 2 dt, or integrating it all over, what I will get, it will, I get 3 by 2 multiplied by here, this will be t 3 by 2 divided by 3 by 2. Okay, these two will cancel out, and here I will have the range which is 0 to x. Okay, so now here what I will get, here this f, for this f of x, what I will have here, this is t 3 by 2, and first putting the higher range, which is x 3 by 2, and then from it 0 3 by 2, what I will get here, I will get x 3 by 2, which is the CDF in the range of 0 to 1. Okay, or mathematically, or I can also write it like, let me write these values. Okay, this of x is what, this f of x is 0 for the value of x less than 0. Okay, it is equal to x 3 by 2 for the range where x is greater or equal to 0 and less than 1, and it is 1 for all the range where x is greater or equal to 1. Okay, so these are all the values which I had to find out. This is 1. Okay, so this is the CDF of the function which I had to find. Okay, after it, what do we have to find out? We have to find the value that probability of x is greater than 0.3 and less than 0.6, and in finding it out, let me find it out here, and here it will be probability of x is greater than 0.3 and less than what? 0.6. Okay. So here it will be what? Here in using the CDF, what I have to write? I have to find the CDF of the higher value, which is 0.6, and from it I have to subtract the lower point, which is 0.3. Okay. Now putting their values, I know the values which are here. So this is x 3 by 2 or 0.6 3 by 2, because now the value of x is 0.6, and putting the uh, power of it 3 by 2, and also 0.3, and the power of it is 3 by 2. Okay. Then evaluating it, what I will get, the answer of it would be 0.3004, which is the solution of part B of my question. Okay. So that's it for today, in which we have found the solution of question 3.21. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 3.22, and this is chapter 3 related to the random variables and probability distributions. So the statement of this question is three cards are drawn in succession from a deck without replacement. Okay. So find the probability distribution for the number of spades. Okay. So here we have to see that the probability distribution for the three spades. Okay. So the given data here is, in given data we have to make some suppositions as well. Here let me take this and for no no spade. Okay. And as for the spade. Okay. What we have here, we will have to bring out three cards. So three cards we will have. Okay. So in these three cards we can either have zero spade. Okay. We can either have one spade, two spades, or at most three spades. Okay. So we have to find the probability of each of the spade here. As you know that we have here, these are the number of spades in three terms. Okay. So let me solve it first. And in first turn, where we have the probability of spade equal to 0, what can be the options here? We can have here the event where all of the three items here are non-spade. So it would be n, n, n. Okay. So here, if the three items are non-spade, what it can be? It will be all the items in the first will be the 39, because the total number of items here are 52, and out of these 52, 13 are spades. Okay. While 39 are non-spades. Okay, you can see that here we have, if we don't have any spade in the first turn, therefore the total number of items in the first turn I have to pick are 39 out of the total, which are 52. Okay, so this will be the first turn. If one non-spade item has been selected out of it, how many remaining non-spade will be here? We will have here 34, 38 non-spade, and the total items here are 51, because here we have the without replacement sampling. Okay. So here we will have this one, and in the third item, what we will have here, now two items have been selected from 39, so here we will have 37, and out of the 50 we have here. Okay. So this is the overall probabilities of what we have to find out. So these have to be multiplied together, and when I will multiply them together, what I will get here, I will get 703 divided by 1700. Okay. So this is what, this is for s equal to 0. Similarly, for the probability of s equal to 1, where we have only one spade, so what are the options I have? So the number of options I will have would be, either the first item will be spade while the other two will be non-spade. Okay, this is the first one. Sorry, this is the first one. Second one would be the second item is spared, while the first and the third one are non-spared, and the third one is the first two items are non-spared while the third one is spared. So this is what this is for the probabilities it has. Okay, so now what do we have to do here in order to do so? Again, using the same terms, like here it will be S and N. Okay, or we have here the probability of N S N. Okay, or here I will have probability of the N and as. Okay, so this is what we have. Now in order to find the probability of them, we can see that these three are independent of each other, so therefore writing their probabilities. So the probability of getting one spared, or the first one spared, is will be what? It will be the 13 out of the 52. Okay, so it will be what? It would be the 13 out of the 52 are the spares. Okay, now when we will get it, what will we get here multiplying this one? Well, let me identify it. It will be here. Now after it, the other one is N, so this N is from the non-spared. So as one spared has been selected, so the total item remaining are 51, while the non-spared are still the same because none of the non-spared has been selected, so it will be here. Okay, so this one is for here. Okay, and the last term here is again non-spared, so therefore as one spared non-spared has been selected, so 38 are here and 50 are the total one which is remaining here. Okay, so you can see that the other ones will also be like the ones we have got here, but in the multiplicative term these will be somehow in different order, but these will be the same item. So therefore what I have to do here, I have to multiply with them 3 as well. Okay, you can see that here for the first item you will get this one, for the second you will get this one, and for the third one you will get this one. Okay, for this one the first two will be the 39 and 38 terms, while for the last term you will have this one. Okay, that's why I have added them all together and put it here, this 3. Okay, so now by combining them all, what I will get here the answer of it will be 741 divided by the 1700. Okay, this is for the probability of S equal to 1. Okay, now similarly let me go down somehow. Okay, and here in order to find the probability that S equal to 2, what will be the options here? Here the options would be the probability that either the first two are spared and the last one is non-spared. Okay, and the second one here is the first one is the non-spared while the last two are spared. Okay, and the last one here is the mid one is the non-spared while the others are spared. Okay, so this is what we have the probabilities. Now in order to do so, what do we have to do here? Again, the probability of SS and okay, or the probability of N S S, or the probability of S and S. Okay. Now putting their values here, the probability of SSN, so probability of S1, then probability of S2, and then probability of N, and similar will happen for them as well. So therefore I will put here 3 as well. So for the probability of first paid, what I will have here, I will have 13 divided by 52 because the total number of spades here, if one spade has been selected, so the number of spades remain here would be 12, while the total number of items will be decreased to 51, and the last non-spade, as none of them is the non-spared here selected, so therefore the non-spared will remain the same and it will be 39 while the total number of items are reduced to 50. Okay, and similar will happen for them as well, because you can see that the options here we have are the two spades and one non-spade. So similar is for here, so therefore I have to put here 3. And this is what you can see yourself as well, that when you will do it for the same items here, you will get the same answer, and therefore I am putting here this 3. So after multiplying them together, what will be the answer of it? Here the answer of it will be 234 divided by 1700. Okay, so this is for probability that s equal to 2. Okay, now let me move down somehow more, and for it the 3 spades. Okay, so the probability that we have spades equal to 3, so it would be what? It is only the item where we have spade, spade, spade. Okay, so this is what we have. Now let me put their values here. The probability of spade 1 multiplied by the probability of spade 2 and multiplied by the probability of spade 3, 3 spades. So now when one spade is selected out of the 13, so here the probability of it is 13 divided by 52, multiplying it with the probability of spade 2 when 1 is selected, so it will be 12 divided by 51, and the third spade is out of the same spade, so therefore it will be 11 by 50. Okay, so what will be the answer? The answer of it will be 22 divided by 17. Okay, so this is for the spade equal to 3. Okay, so these are all the options we had here, and from it we have found out all the ways from which we can get it. Okay, so now let me plot them here, and in plotting them what I have to do here, let me write their values. Okay, so in writing their values, let me use it here, and here let me use them with green. So this is x, this is f of x, which is the probability, and let me write their values. So the first value of x or spade is 0, the second one is 1, then 2, then 3. Okay, so these are all the values it has. So this is the values of x. Now putting their values, the probability that spade is 0, that is given here, that is 703 by 1700. Okay, that is already given. For spade equal to 1, that is 741 divided by 1700. For two spades, this is 234 by 1700. Okay, and the last one for three spade was 22 divided by 17. Okay, so once you will add them all together, you can see that when you will add them all together, like 703 divided by 1700 plus 741 divided by 1700 plus 234 divided by 1700 plus 22 divided by 1700. So it will be what? This would be the 1700 and 703 plus 741. This is 1444. So 1444 plus 22. So that is 1466. 1466 plus 234. That would be 1700, and you will see that these will cancel out, and ultimately you will get 1, which is what? Which is the condition for any probability distribution, that when you add all the probabilities in it, what will be the answer? It will be equal to 1. Okay, so that's it for today, in which we have seen the probability distribution for one of the problem of the probability. If you have any question, you can ask me in the comment box. See you soon.